Hello mga ka-tribes! Welcome to Daddy Brew TV. This is your adventurous math teacher. So for today's video, let's talk about Lesson 3, Quarter 4, the estimation of parameters. First topic is the point and interval estimation. What is point and interval estimation? Point estimation is the process of finding a single value called point estimate from a random sample of the population to approximate a population parameter. The sample mean is the point estimate of the population mean. The variance of sample is the point estimate of the population variance. Example 1. The sample mean is 45.12 and the population mean is 46.51. What is the point estimate? Solution. The point estimate is the single value 45.12. Example 2. A teacher wanted to determine the average height of ABM grade 11 students in their school. What he did was to go to one of the 9 sections in ABM grade 11 and then took their heights. He computed for the mean height of the students and got 165 centimeters. Solutions. The mean height 165 centimeters is not a good point estimate of the population mean. The teacher should have randomly selected the members of the sample from the entire ABM grade 11 population using either simple random sampling or systematic random sampling. Take note, a researcher should not expect the point estimate to be exactly equal to the population parameter. However, any point estimate used should be as close as possible to the true parameter. Data should be carefully collected. Sampling should be done at random, and the sample size should be large, especially when the population distribution is not normal. Different samples of size n taken from the same population produce different results. In the case of sample mean, the result is affected by the presence of outliers. These are data that are numerically too far from the rest of the data. Example number 3. Consider the population consisting of the values 6, 2, 8, 9, and 3. Find the population mean. To find the population mean, let us plot the following population values in a table. As you can see, there are 5 population values, therefore, there are 5 observations. These are 6, 2, 8, 9, and 3. Getting the summation of the population values, we have 28. So, population mean is computed using the formula mu is equal to the summation of x over capital N. Replacing summation of x equal to 28 over 5 observations, and therefore the population mean is 5.6. Now, consider some possible samples of size 2 drawn without replacement from the population. So the samples now are 6.2, 6.8, 6.9, 6.3. Getting the mean, we have 4, 7, 7.5, 4.5. The computations are indicated on the third column. Each mean of each sample is a point estimate of the population mean. Consider some samples of size 3 drawn from the same population without replacement. The samples are 628, 629, 623, and 289. So the means are 5.3, 5.7, 3.7, 6.3. The computation is given on the third column. Each mean is a point estimate of the population mean. Each is typically different from the population mean 5.6. Now, consider some possible samples of size 4 drawn without replacement from the population. The samples are 6289, 6283, 6893, and 2893. Getting the mean, we have 6.25, 4.75, 6.50, and 5.50. The computation of the mean can be seen on the third column. Each mean is a point estimate of the population mean. Each is typically different from the population mean 5.6. Now, let's have last two examples. For example 4, the following are systolic blood pressures of all teachers in a private high school. Compute the following mean, or compute the population mean. To compute the population mean, let us put in a table. Take note, there are 5 columns in this given table. Therefore, in each column, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have 5 columns, right? So 10 times 5, meaning there are 50 systolic blood pressures or 50 teachers. Okay? So the sum for each column is 1,295, 1,237, 1,293, 1,230, and 1,225. So we are now ready to determine the population mean, denoted by the formula mu is equal to the summation of x over capital N. Substituting now the summation of the values, we have 1,295 plus 1,237 plus 1,293 plus 1,230 plus 1,225 divided by 50. And that is now equal to 6,280 over 50, which is equal to 125.6. And that's the population mean. Now, for example 5, assume that the following systolic blood pressures were randomly selected from the 50 observations in example 4. Compute the sample mean. Now, how many blood pressures? There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So there are 25, right? Now, to compute for the sample mean, again, let's put it on a table and add. There are 1, 2, 3, 4, 5 columns. So the summation for each column is 645, 637, 643, 620, and 625. So we are now ready to determine the sample mean. Denoted the formula x bar is equal now to the summation of x over small n. And we have now the summation of x equal to 645 plus 637 plus 643 plus 620 plus 625 over 25. And that is now 3,170 over 25, which is equal now to 126.8. Therefore, the sample mean equal to 126.8 in example number 5 is still different from the population mean equal to 125.6 in example number 4. It means it is better to approximate the population parameter by determining a range of values within which the population mean is most likely to be located instead of using the point estimate. This range of values is called confidence interval, and that will be the part 2 of our discussions. Thank you for watching. See you on my next video. Bye.